Normal distribution tables. Type 1, finding the probability. So in the PowerPoint I went through one or two basic examples. We're just going to recap on that. So we're going to have a look at three basic ones to start. In other words, finding the probability where we're just given one z-score value. So the first one we're going to have a look at is finding the probability that z is less than or equal to 1.77. So the first thing we always want to do is do a little sketch for ourselves. So 0 is there, so 1.77 is approximately there. So less than means all of this area here is going to be shaded in. Okay, so we're trying to find the area represented by the shaded bit in red. In other words, the probability. So to find that value, we go to our tables on page 36. So our normal distribution table is page 36 and page 37. So here I have a nice image where it does all of them on one table, but yours is broken down into 0 to 1 and then from 1.1 to 3. So that part of the slide would be page 36 and this part of the slide would be page 37 for our tables, okay? So if we're going to 1.77, so we'll have to go down. Here's our z-score in the top left corner. So we're going down to 1.7 and then we need to go across until we get to 0.7. So in other words, I'm coming all the way down. And again, my advice is always use a ruler. So I would be lining up a ruler where my dotted red lines are. And we can see then that we end up with a value of 0.9616. So in other words, the probability that z is less than or equal to 1.77 gives us a value of 0.9616. In other words, the area shaded there in red is 96.16% of that graph. Okay, so what happens then if we have one that is greater than? So if we have the probability that z is greater than 1.6. So again, I'll do myself a little sketch and I mark in my z-score on my graph. So 1.6 is approximately there. And this time we're looking for greater than 1.6. So in other words, all of this area here is the area that we're looking for. So we're looking for the probability of lying in that section. So therefore, I cannot get greater than in my tables. It only is representing less than. If you look up here in the top corner, this little graph is what's showing you that it is always less than the z-score. Okay, so it's not greater than. And again, you have a similar graph on page 36 in your maths tables. So to get greater than 1.6, what I have to do is look at the fact that if I get the graph 1.6 and I get all of the area less than 1.6, which I can find from my tables, then all I have to do is subtract that value from 1, and that will leave me then with the blue bit, the bit that I'm looking for. So in other words, we say the probability that z is greater than 1.6 is equal to 1 minus the probability that z is less than or equal to 1.6. So therefore, if I sub in my values, and again, it doesn't matter really if you forget the less than or equal to here, because it's greater than 1.6, everything underneath that would be less than or equal to. It would be proper maths to write it like that, but if you forget it, you're not really going to be penalised, okay? So again, if I go to my tables and I go 1.6, let me just erase all of these ones here now. Then 1.6, well, it's 1.6 exactly, so there is no value afterwards. So if you look at the top of the tables there, that's 0.00, so that would be 1.600. So therefore we have straight off the probability is 0.9452. So if I take my calculator and say 1 minus 0.9452, then that gives me a probability of 0.0548. Okay, so very small percentage in that value there. Okay, so the next one then would be is when we get one that is a negative value. So again, I'm just going to move this down. So if we're looking at a negative value, we want to say, for instance, find the probability that Z is less than minus 1.2. So again, the first thing I will always do is sketch my little graph. There's 0. So minus 1.2 is over here. And again, we're looking for less than minus 1.2. So it's going to represent all of that shaded area there. So again, if we're looking at our tables, we cannot go beyond 0. So in other words, the tables only represent, from 0 onwards. And again, looking for less than in that direction. Okay, so therefore we need to look at how can we find this out. So again, we're using the fact that we have symmetry. So therefore that is the same as 1.2, and it would be symmetrical with greater than 1.2. Okay, so in other words, this probability is equal to the probability that Z is greater than 1.2. But of course, we can't find greater than. So this is like the previous one there in 2. Well, it's the same as saying 1 minus. So again, if I look at the graph, well, if I get less than 1.2, I get all of this green area. And the green and the red together make a total of 1. So if I get the probability that Z is less than or equal to 1.2 and I subtract it from 1, then I'm left with the red bit, which is greater than 1.2. And greater than 1.2 is the same as less than minus 1.2. So in other words, if I write that down, well, that's equivalent to 1 minus the probability that Z is less than or equal to 1.2. So again, we go to our tables and we say, well, what's 1.2? Well, 1.2, if I just rub out the last one, 1.2 is 0.8849. Okay, so we'd go 0.8849. And if I subtract that from 1, we end up with the probability of 0.1151. Okay, so for the second type, then we're going to look at, sorry, not the second type, sorry, we're going to do one more example where we're looking at a range of values. So just pause. So for the range of values, we're going to take the example that we had on the PowerPoint there, where we had the value that's lying between minus 1.3 and 1.3. So again, we want to find the probability that minus 1.3 is less than or equal to the z-score, which is less than or equal to 1.3. So again, I sketch my graph to represent this. So I have 1.3 and minus 1.3. So we're trying to find the shaded area that's lying between these. In other words, what's the probability of lying between these two values? So of course we can't use our tables to get that directly. So we're going to break that down into two separate graphs. So essentially we have less than 1.3. And then that's subtracted. Ooh. And then we have minus 1.3. So if I get those two separately and then I subtract them, well then what I'm doing is I'm removing out that little bit to the left and I'm left with the range between minus 1.3 and 1.3. So therefore, what does that look like? Well, that graph is represented by the probability that minus 1.3 lies between, is less than or equal to z, which is less than or equal to 1.3. This graph here is the probability that z is less than or equal to 1.3, and this one is the probability that z is less than or equal to minus 1.3. Now, of course, we can get the probability that z is less than 1.3 from our tables, but I can't get less than or equal to minus 1.3. But we know that's the same as the probability that z is greater than 1.3, and we know greater than 1.3 is the same as saying 1 minus the probability that z is less than 1.3. Okay, And then if I get rid of the brackets, well, what does that leave me with? It leaves me with the probability that Z is less than or equal to 1.3 minus 1 plus the probability that Z is less than 1.3. They're the same, so essentially it's 2 times the probability that Z is less than or equal to 1.3 minus 1. Okay, so you're just breaking it down into 2 separate parts. Okay, so now if I go to my tables and I say, well, what's the probability that Z is less than or equal to 1.3? Well, if I go back here and I just delete the last example, well, we're looking for 1.3, so that's going to be 0.9032. So we have 0.9032, and then I have to subtract 1 away from that. So we have 2 times 0.9032, and then we take 1 away from that, and that leaves us with a probability of 0.8064. So there's 80.64% of the data is going to lie between minus 1.3 and 1.3. Okay, so if we're looking at another example where the values are not the same then, so we have the second example here where we have the probability that minus 1.21 is less than or equal to Z less than or equal to 0.93. So again, if we sketch our graph, so again, sketching the graph makes it so much easier to see what's going on. So we have minus 1.21 and then we have 0.93. So a bit of a narrower range. And again, we're looking for all of that. So of course, how can we find that area? Well, we can split that into 2 parts. So we can say less than 0.93, which is going to be all of that area there, minus the probability that it is less than minus 1.21. So again, if I write that as a formula, well, that's the probability that minus 1.21 is less than or equal to Z, which is less than or equal to 0.93, can be written as the probability that Z is less than or equal to 0.93 minus the probability that Z is less than or equal to minus 1.21. And of course, we can't get less than a negative Z score, so therefore that's going to be 1 minus the probability that Z is less than 1.21. And then if I get rid of my brackets, with the probability that Z is less than or equal to 0.93 minus 1 plus the probability that Z is less than 1.21. So we then go back to our tables to get the probability that Z is less than 0.93. So again, just remove the last one. So 0.93, well there's 0.9, and now I have to go out to get my 0.3. So that's 0.8238. Minus 1 plus the probability that Z is less than 1.21. 1.2 is there, and if I go out, did I get 1.21? So that's 0.8869. Okay, so if we add that, what are we left with then? So we have 0.8238 minus 1. And then we have plus 0.8869, and that gives us a Z score, or probability value, of 0.7107. Okay, so in other words, 71% approximately is between minus 1.21 and 0.93. Okay, so I'll stop this video here, and that's type 1, and then the second video will look at type 2.